Hello, my name's Carter, and today I'm going to teach you about Pascal's pyramid. And to start this off, I'm going to do a quick overview of Pascal's triangle and its applications. Um, Pascal's triangle, as we know, the middle numbers are the sum of the two numbers above it, so 1 plus 1 is 2, 1 plus 2 is 3, so on and so forth. And there are infinite rows of Pascal's triangle, so this is row 0, 1, 2, 3, and 4. And its main application is in binomial distribution, which is right here. Um, right here. I gotta make sure I get that in there. Um, it is the sum of two numbers raised to the nth power. And as a little example here, I'm gonna erase this 2. I'm gonna erase this n and then replace it with a 2. There we go. And I'm gonna solve this, and then I'll show you how Pascal's triangle relates to this. So a plus b times a plus b, and then use FOIL to get a squared plus ab plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. And now I'm going to highlight the coefficients in red. So there's an implied 1 here, 2ab, and then another implied 1 here. And looking at the coefficients, so 1, 2, 1, we can look back at Pascal's triangle and see 1, 2, 1. We can also see that this is the sum of two numbers squared, and that this is row number 2. So that is the main correlation between Pascal's triangle and binomial distribution. And so you're wondering, what does Pascal's triangle have to do with Pascal's pyramid? Well, imagine taking 3 copies of Pascal's triangle and pasting them onto a pyramid. This is Pascal's pyramid. And to help visualize this, I'm going to cut to a Google SketchUp model of Pascal's pyramid that I made right now. I'm back, and I have with me my 3D model of a pyramid. Sorry. And if I remove all the sides, you can clearly see that this is Pascal's triangle. This is Pascal's triangle, and this is Pascal's triangle. So all 3 sides are Pascal's triangle. And so you may be asking, what's the big deal? Well, it's this 6 and these 3 12s. And I'm going to explain to you how these pop up and what's the big deal. I'm going to start off with explaining this basically layer by layer. So I'm going to remove the bottom layers and just start off with layers 0 and 1. So if I remove, let me zoom in a little bit. Okay, if I remove this red tint, I can see that. Well, I can kind of see that. You know, this one goes with this one and this one, and it's kind of straightforward. But yeah, it's kind of straightforward. It's Pascal's triangle, but just we're looking on it like we're looking at it from the inside rather than like from the outside. You know, here. Yeah, we're looking at it from the inside rather than like the outside. And if I remove this stuff and add in this, this is layer 0, or sorry, layer 2 of Pascal's pyramid. And if we look, well, 1, 2, 1 is also layer 2 is also layer or row 2 of Pascal's triangle. And so if we go vertically, we can see how these two ones add together to get 2. This one and this one add to get 2. 1 and 1 add to get 2. And so I'm going to remove the ones, add in the next layer, and so I'm going to show you how to get this 6. We remove this, and if we look at this back layer here, or this back side, 1 and 2 add together to get 3. 2 and 1 add together to get 3. And this is similar for the other sides. 1, 2, 1, 2, 3, 2, 1, 3, and for the other side as well. So now this 6, to get that, you need to add, if we look straight up from the very top of the pyramid, looking straight down, 2 plus 2 plus 2 is 6. And so this guy forms a little triangle, and these 3 2's add together to get 6. So I'm going to remove these 2's, add on the next layer, and then remove the green. And it looks a little strange. Remember that the red numbers are above the blue numbers. And so if we look at this back wall again, here, I can put it there, yeah. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And then if we go vertically again, we have 3 plus 3 plus 6 is 12, 3 plus 3 plus 6 is 12, and then 3 plus 3 plus 6 is 12. And again, these form little triangles. And this is Pascal's pyramid. And so the next layer would continue on, and it would just go on forever. And so I told you that the application of Pascal's pyramid, of Pascal's triangle, was binomial distribution. Well, the application of Pascal's pyramid is trinomial distribution. So if I add these numbers back, I'm going to show you how the sum of a plus b plus c all squared is how that relates to this layer of Pascal's pyramid. And so you can see that right here. A plus b plus c all squared. I have it shown here. And then simplification. This is my final answer. And it may look a little strange to you, but if I try to line up the answers into or the terms into a triangle, you see, okay, 1 plus 2 plus 1, or yeah, the 1, 2, 1, 1, 2, 1, 1, 2, 1 that you see with Pascal's pyramid here. 1, 2, 1, 1, 2, 1, 1, 2, 1. So now looking on, one of the big questions could be, what if the base changed? You know, here I have a pyramid-like base. Well, what if I change this base to a square or a hexagon, so on and so forth? How is that going to change what these numbers look like? You know, how are the numbers on the inside going to change? And so that's the big question. And thanks for watching my video. See ya.